the external hard drive works so much better compared to the flash drive, just because it is a lot faster. So we're going to have our first exam on Thursday. We talked about that last Thursday already. It's going to take up the entire class period. It's open book, open notes, but no electronics. So that means no cell phones. You can probably use a simple calculator like those $1 or $2 ones from the Dollar Tree. That should work okay.
So we're going to need a calculator. We're going to need a calculator.
I don't think so. But some people just feel better when they have a tool available. The Dollar Tree actually sold scientific calculators for $1 at the beginning of like the academic year. I found ones that were $1 literally. $1 for a scientific calculator. Now it's not a TI-89 or anything fancy like that. It cannot do calculus or anything like that. But it can do trig, all the sine, cosine, log, exponent, tangent, you name it, fractions,
Is that
square
going to be on
root.
the exam? Is that what's going to be on the exam?
No.
I was about to say.
No, this is not a math class. So we are not going to have those topics in the exam. So what the exam will cover will be all the topics that we have talked about up to, but before we talk about programming. Okay, so let me just go to the website first so you can see what topics will be included. So everything that we have talked about here, and even up to what's inside the computer. Little talks in the computer, that's work in progress. That's actually when we got digress. When I started digress in the programming. So little talks in the computer is not included in the exam, but everything before that will be a part of the exam. That's within the scope of the examination. The exam is not going to be much memorization based. It's going to be application based. In other words, I'm relying on you guys to read and understand the material, and then the question will test whether you can understand the concepts, but not whether you can memorize the concepts. And that's why it's open book, open notes. Okay, if you kind of remember the concept, but you cannot remember exactly the name or little details of the concept, you can just look it up. It's no big deal.
So if we printed out all those things that we talked about, we could bring that in?
Yes, absolutely. Yep. You can bring in textbooks if you want to. Okay, for instance, when we talk about applications, if you have a book, or if someone has an earlier version of the textbook for this class, because I told you guys that you would not need it in this class. But if you have access to one and you feel that some of these content is better explained in the textbook, bring it in. Okay, anything that's printed or handwritten, is okay. So that really gives you a lot of options. I mean, if you go to Wikipedia, you find that a certain part of a page is useful to you, print it out and bring it in. The difficulty of bringing in too much stuff is you cannot find the information because you have a mountain of material. So the best way to prepare is really to read the notes, make sure you understand it. If you don't understand, you can either use Google or come to my office hour, to kind of clarify the concepts. Are there any questions about the material that we have covered up to this point? And remember, programming is not going to be a part of this exam. Okay, just everything up to what's inside a computer. But the digitization process will be in it. Okay, sampling rate, sampling resolution, those concepts will be included. Yep.
Talk about different open source programs. Is it important to know the specific program, like names?
If it is mentioned, I might ask you about it. If it is not mentioned, obviously I cannot, ask you to do research on the fly. Yep.
Topic 1, everything from topic 1.
Everything from topic 1, and then certain parts of topic 2. So in topic 2, everything except for the last topic. The Wikipedia thing, audio resolution, it's really kind of a longer topic. You have to understand the concepts that we talked about in the class, which included, like sampling rate, which is how often do you convert audio signal into a data point to be stored. So that's basically sampling rate, and then you have sampling resolution, which is how many steps you break one sample into. Are you breaking it up into 16-bit, which is 65,536, individual levels, or you're breaking it up into 256, which is an 8-bit, sampling rate.
And those,
Sampling resolution.
and those kind of questions will be on the exam?
Those questions will be in the exam. Yep. So the exam will test your understanding. It's not to test whether you can memorize. Okay. Are there any questions about exam 1? Open book, open notes. Yep, go ahead.
You say that the exam is going to be resolution conversion, so we have to use some formula for that?
Conversion
Yes.
for base 2? Base 2 conversion, you can probably do it, using a piece of paper and pencil. And I will probably cast it as a problem, like, okay, you have this amount of money as a change. So how do you pick your bills and coins? Okay, you have $16 bills, $8 bills, and I'm just going to be asking you how many of each would you need. Okay.
How about the binary, conversion?
Binary conversion, that's what I just said. Because that's basically the mechanism.
In that way, but not like that. So you have $57 in binary, system, how much you're gonna have?
But let's do that, okay, since you're asking the question, let's try that out, and see if you can do it, okay? So let me use, I'll use a spreadsheet for this purpose because, it gives me the grid and the tabular format. Did I even start it? I thought I did. I guess I didn't. Okay, so we're going to talk about a little bit about base conversion. We talked about this already in the class. It's just that I want to do it one more time so that you guys can kind of figure out how to do this. All right. So one way to do it, is to look at things, from the perspective of dollar bills, and you're trying to make up a certain value out of these particular units. All right. So we'll start with something that looks kind of nasty. Okay. So we'll start. Let me zoom in first. Okay. So we have $64 bills, $32 bills, 16, 8, 4, 2, 1. And then we have the fractions. One is 0.5, which is a $half, and then one is 0.25, which is a $quarter. Okay. Oops. What happened to the quarter? Oh, there we go. And I will shrink all of these into smaller, narrower columns. Okay, so there are two ways to make use of this little grid here. The first way is, okay, let's see whether we can convert from base 10 to binary. Okay, so to convert from base 10 to binary, it's kind of like this. Okay, so let's see, use this example here. I'm using column K, as the actual value to do so you have to convert it. I'll just randomly pick a value here. I'll just pick 47 and 50 cents. Okay. So now I want to convert this value, which is in base 10, 47.5 is a base 10 number. I want to convert it into a base 2 number, okay? In the exam, I will give you a similar format, okay, which means, I will give you the columns, and you have to tell me, how many of each you will need. The limitation is you cannot say, I'll just give you 150 cents and then 47 $1 bills, okay? That's not going to work, right? So you can only have 0 or 1 of each particular value. Okay, that's the limitation. You can have 0 or 1 of each particular value.
This is, of course, assuming that the balance will be 0. There's not going to be any leftover.
Correct. Yeah. So you have to represent 47.5, but only using the units that are represented by column B to column J. Okay. For each value, you can have 0 of it, or you can have 1 of it. Okay. So we'll get started with this one. We have 47.5. So with 47.5, do you think we have any 64s? No, no 64s, put a 0 here. Do we have any 32?
Yes.
Okay, we got, well, it's either 0 or 1, so when we say there is a 32, there's exactly 132. Now, after the 32, this is where a calculator can come in handy, because what you can do is to say, okay, I'm keeping track of how much is left from that amount. So with a spreadsheet, I can actually just do something like this. I can say 47.5 minus 32, and that's how much is left here. Now, since I only have $15.50 left, do I have any 16s? No. Do I have any 8s? Okay, got one 8. So after you do the 8, or after you include an 8, then your amount is changing again. So this time it is 15.5 minus 8, which is 7.5. Is that working out just okay? Okay. With 7.5, do we have any 4s? Yep, we got 1. So you do the same thing again. 7.5 minus 4 is 3 point something. Does that have a 2? Yep, it's got a 2. So with this one, you can just kind of do hand calculated. Then we have a 1. Then we have 0.5 left. So we have one of these, which is a 0.5. And then we got nothing left. But we are not done yet because we still have to specify that we don't have any quarters. So put a 0 here. And now we have our binary number. Okay, the binary number in this case is 010111.1. Okay, there's a point right here. So there's a point between these two numbers. Is that okay? I mean, base conversion. So this is converting from base 10 to base 2. Can we do it the other way around? If I give you a base 2 number, do you think you can convert it back into a base 10 number? Yep, go ahead.
Why did you put the point between 0.5 and 1.25?
Sorry?
Why the point is between 0.5 and 1.25?
Because that's where the separation is. Column H is the last unit that is a whole number, and then column I is representing a fraction already.
Why don't you put it between the 1 and the 0.5?
You've got the box.
Oh yeah, you can do that too. I mean, it's basically between column H and column I. The point is between these two columns. So this number, as a binary number, there's a point right here where my mouse pointer is. Is that okay? Because the point in the decimal number is the separator between how many 10 to the power of zeros, which is 1, and how many 10 to the power of -1, which is 0.1. So the point is to separate the last whole unit versus the first fractional unit.
So it should be between H and I.
Between H and I, correct. In other words, if I were to spell out this number, it's going to be, okay, let me just put it here. So if I were to spell out this binary number, it would be 010111.10. That's the way it is spelled out as a binary number. Is that okay? All right, so let's try something else. Let's try to reverse the process. I give you a binary number, and you convert it back into a base 10 number. So let's say we have a binary number that looks like this. Okay, so here we have a binary number. The binary number itself, if you spell it out, it's 10010110. Oops. Yep. 0. It's 1001010.01. Okay, as a binary number. I want to convert this back into a base 10 number. Yep.
4.25.
It'll be, yep, we just have to add up the columns, right? Okay, whenever you see a 1 for that column, add that value to the sum, and that's all we have to do. So in this case, if I'm doing the calculation using a spreadsheet, you can use a calculator in the test. We have 164, we don't have any 32s, we don't have any 16s, we got 1 8, we got no 4s, we got 1 2, we have no 1s, we have no 0.5s, but we do have 1.25. So the decimal representation of the same value is 74.25. Does everybody understand? Let me just click this so you can see the formula here. Does everybody see how I convert from base 2 back into base 10? It's just locating, where we have the ones, and then just add those particular powers of 2 to the sum. All right. Are we still doing okay? Yep.
It's very easy like that.
It is easy.
Because the other way in math, like you have to divide it by 2 by 2 by 2, and that
Right.
sequence goes like this. So
The division method is more general. In other words, this method only works well with binary numbers, but the division method will work well with any base. So if you want to convert a number into base 3, base 5 in some really odd base, it will still work. With base 2, this works really well because you're just comparing. You're basically asking, with 47.5, is it greater than or less than or equal to 64, right? If 47.5 is greater than or equal to 64, that will make a 1 for that column. If it is less than 64, then you can put a 0 there. But every time you put a 1, you have to remember, oh, okay, I gave you that much already, so what is the remaining portion that I have to give you? So it's really the same process of trying to figure out, how many, dollar bills and coins to give someone as a change. In the process, it really is the same process, except this one is actually easier than dealing with all the bill values that we have, because this has a regularity. There's a certain pattern to it, but with dollar bills and whatnot, there's no particular pattern. Are we still doing okay so far with binary numbers? Okay. Now this is actually very useful, not only for people who want to get into computer science and do programming and whatnot. It's also particularly useful for people who want to get into networking, because that's how the net mask, and all the other stuff, related to the address of an IP address. This is how everything is done. They're all specified in binary. Okay. Any other questions about binary conversion? From base 10 to binary, and then from binary back into base 10. No questions? What if I ask you to convert it to base 3? Yep, go ahead.
So this is, I thought it was base 2, this is base 10.
This is, okay, the first part here, okay, what we went through, this part here was converting from base 10 to base 2, because I gave you the number 47.5, and then we ended up with the binary number, which is 010111.10. So the first half, was a demonstration of how to go from base 10 to base 2, and then the second half, which is this part here, was was exactly the reverse. I gave you the binary number, and we're converting it back into base 10. But in either case, it does not involve anything more than addition, subtraction, and comparison. Are we still doing okay so far with this part? Okay. All right. Let's move on. And well, since we already understand how to deal with this, let's make it a little bit more fun. Okay. So we'll go ahead and I'm gonna copy and paste this stuff into the next sheet. I cannot shrink that one. I can shrink everything else. Let's see if we can deal with base 3. Okay, it's the same concept. Okay, in base 3, it really is the same concept, except I cannot use these particular values because, well, base 3 is base 3 is a little bit odd and difficult to deal with. Let's do base 5, okay? So let's go ahead and change all of this. Okay. If I'm dealing with base 5, how do you think I'm going to change all of this stuff here? It'll be multiples or powers of 5. Not multiples, but powers of 5. Okay? So the next question is 1 a power of 5? It is, okay? It's 5 to the power of what?
0.
0. 5 to the power of 0 is 1. Okay. What is 5 to the power of 1? 5 to the power of 2? 25. 5 to the power of 3? which is 25 times 5.
125.
125. 125 times 5. 625. Okay, let's stop there. Okay. How about on the other side? What is 5 to the power of -1? In other words, 1 divided by 5. It's 0.2, right? What is 0.2 divided by 5? 0.04. Okay? Does everybody see the pattern here? Okay? Is this the same pattern that we see in base 10 numbers and also in base 2 numbers?
Yes.
Absolutely, right? Because in base 10, what we put here is 1, just the same. But what we put here is 10, because 10 is 10 to the power of 1. This is 100, because it's 10 to the power of 2, 10 to the power of 3, which is 1,000, 10 to the power of 4, which is 10,000. On the other side, we have 0.1 here, because that's 10 to the power of -1, and this is 0.01, which is 10 to the power of -2. So that's the general pattern of how we represent value using whatever base. Okay, it's really just that base to the power of 0, that base to the power of 1, to the power of 2, and so on. And that's the way you work it out on the left-hand side. On the right-hand side, it is that base to the power of -1, that base to the power of -2, and so on. Is that okay? All right. So in this case, let's try to figure out how to do the actual conversion. I have to give you a value in base 10, and we can just see whether we can deal with it. Okay, so let's try. This time we can try a fairly large number here. Let's try 415 point. The fractional part I have to be careful because it has to be something that can be represented. So I'm just going to have to pick a particular value that works out 48. Okay, that's a pretty good one to try. Okay, so this is the decimal representation. It's a base 10 representation, and I want to convert it into a base 5 number. Where do we start? How did we start last time?
On the D.
On the left-hand side, right? We tried the largest numbers first. Okay, so we should do the same thing here.
0.
Remember, this is nothing more than trying to give someone change. Okay, this time the value of the change is $415.48. But instead of using the usual bills and coins that we have, you have you have bill values at $625, $125, $25, $5, 1, and then you have coins of 20 cents and 4 cents. Those are the things that you can work with. And I want this particular value, which is $415.48. So it's the same process. It's just that we are changing the rules a little bit here. Okay. Do we have any $625?
No, 0.
Okay, 0 of that. How about 125?
3.
We got 3 of those. Okay, so that would have taken care of 375. Yep. Go ahead.
Oh, you said it was only 0 and 1s.
But that's only for base 2 numbers. Now, since we're dealing with base 5, then we can have 0 to 4 of each value. In other words, depending on which base you're dealing with, the amount or what you can have for each value is from 0 to the base minus 1. So if we're dealing with base 5, then you can have 0 to 4. If you're dealing with base 10, then it's 0 to 9 for base 10. Okay? You already know these rules, okay? So let's just say that you have $1 bills, $5 bills, and $10 bills, okay? Would you give someone 5 $1 bills?
No.
No, because you have a $5 bill that can represent exactly the same value. Is that making any sense? So in this case, why would I give someone 5 $5 bills when I can give that one person a single $25 bill? It's the same rationale. Is that okay? Okay, but it's the same reason. Okay, we already understand all of this stuff, by dealing with the usual stuff that we deal with. It's just that we are tweaking the rules a little bit and making it even more regular than the money system that we already use. Okay, so but we do have to keep track of the remainder. So the remainder in this case is 415.248 minus 3 times 125. And that's how we end up with a remainder a remainder of $40.48. Does everybody understand why I end up with only $40.48 after giving the other person three $125 bills?
375, 415 minus 375. Right?
Exactly. Yep. Is that what you do when you try to figure out, how to give someone, money for change? It's exactly the same process. Okay. All right. So now that we have $40 left, do we have at least 125?
One.
We got one. Okay. So we do the same thing over here. We just say, it is this number minus 1 times 25. I could have just typed it, but this way it's more general. So we got $15.48 left. Okay. Do we have any $5 bills?
3.
We got 3 of them. Exactly. So in this case, you can see that it's not a comparison anymore. It's not just that 15.48 is greater than or equal to 5. We actually have to do a division. Okay, we have to do a division of 15.48 divided by 5 is 3 point blah blah blah. So we just take the 3 and say, okay, we need 3 $5 bills. Okay, so we got 3 of these, and as a result here we have this number minus 3 times 5, which gives us 48 cents left. So do I have any $1 bills?
0.
0 of those. Okay, that's good. And you know what? I'm going to, I guess I don't need to specify that here. Okay, let's move on to point 2. Do we have any point 2 or
2.
20 cents in 48? We got 2 of those. Okay, good. So what we have left here is the 8 cents. And how do I take care of the 8 cents using 4-cent coins?
2.
We just need 2. Exactly. You know what? You have done it.
So it's 0, 3, 1, 3, 0.22.
Exactly. Okay, that's how you read this number as a base 5 number. It is 0.22. Okay. Is it really hard? No. No, it's just bending the rules that you already understand. Using exactly the same procedure, but bending the rules a little bit, and you have base conversion. Yep.
So in a sense, if you wanted to make sure that amount was correct or math is correct, you would reverse those numbers.
Correct. Let's go ahead and do it. Let's reverse it and see whether we end up with that number. Okay. Okay. So if you're reversing this process, then you are just adding up the product of how many of each value, right? So you start with 375 because that's 3 times 125, and then you have 125. You have 3 of 5, which is 15. You have 2 of 0.2, which is 0.4, and then you have 2 of 0.04, which is 0.08 together.
Add them together.
And then you add up all these numbers. Sorry?
And then you add them together.
Yep, you just add up these numbers. See, I'm really lazy. I just use Excel the spreadsheet to do it. But this is a good illustration of what you can do with a spreadsheet program. This is really just scratching the surface of what you can do with a spreadsheet program, but you can already see how useful it is. If I were to use a calculator like a regular calculator, it would be a little bit harder to keep track of the numbers, and I could not figure out, how did I get this number? This way I know exactly how I got a particular number. Okay. So we just double checked, okay? As you said, we just double checked to make sure that this representation in base 5 will give us the same value as 415.48 cents. All right, are we doing okay so far with base conversion? Not only with base 2, but now we're dealing with base 5. Now base 3 is a little bit insidious because the fractions of base 3 is hard to represent in base 10.
Can we try that?
Because it'll be 0.33333, and then the next one it would be 0.111111, and so on. So it makes it kind of hard to do the base conversion. It's not exact anymore. We can approximate, but we cannot. It cannot be exact. We also do base conversion, especially the fractional part. How many of you is a machinist, or you work with machines and sockets and tools like that? What do they use how do you size a wrench in using the SAE units?
Metric per standard?
It's in inches, right? SAE is the Society of Automotive Engineers, and when you buy a wrench, let's say you go to Ace Hardware, buy a Craftsman kit, okay? They usually give you either both options, which means that they include both units, or they give you an option. Do you want the metric ones, or do you want the SAE one? The metric one is easy, okay? It's just measured in millimeters. But the ones that is in SAE, they're always measured in inches. But they don't name the inches in like a fractional, like it's a point, blah 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 blah. You can get a wrench like a 3/8, okay, 5/16, and so on. So basically, those are all binary numbers because the divider or the denominator is not the denominator. Yeah, the denominator is a power of 2. Okay, so we have been dealing with base 2 numbers, in our daily life for pretty long already. It's just that we never really realized that we are dealing with base 2 numbers. Okay. Any other questions about the stuff that we just talked about? It's all being recorded. It will be pushed online, so if you need to review it, you can watch the video again. All right. If there are no questions, we are going back to Scratch. Okay, but I will make this session of Scratch related to what we have just talked about here. In other words, let's see if we can make Scratch do base conversion. Okay. Now, the first question you have to ask is it even feasible? Okay. Do you think this process that we have just talked about, converting from any base to base 10 and converting from base 10 to any base, do you think it is somewhat procedural and somewhat mechanical? Yeah. It is. Okay, very good. That's a very good first observation. It is mechanical. So now the next question is, let's see if we can convert it into a language. Let's see whether we can describe the process to do this in a way that the computer can understand. Okay? Now, before we talk to the computer, I do not know. I'm sorry. I did not see them this morning.
They were there.
They were outside.
Oh, they were outside?
He probably has like a limited amount of time for them to stand out.
Right.
Stand out.
You have to contact the DSPS center, and then I don't know their number. I can look it up. Is it okay, or you want to go? Yes, you can. Okay, so, all right, so we are going to write a program to see if we can tell Scratch, the sprite, to do exactly the same thing that we just did. Okay, so now the next question now is, before we even open up Scratch, is how do you tell someone, how do you instruct somebody to do the base conversion that we just did? Now, it's easy because, for someone who know how to, make change, how to calculate changes, out of a particular value, you just say, oh, it's just like that process, except you have, these dollar bills, right? Okay, and that person already understands like 75% of the process. But what if you're telling this process to someone who has never done that? Okay, but nonetheless, intelligent enough to understand what is comparison, what is addition, what is subtraction, and what is division. Okay, so that's the question. How do we, come up with, the description to do this?
Do we got a row sheet?
No, I've somehow lost my row sheet. I have to recreate the grid thing. But I think it really helps to be here today. All right, so we go to education, and then we start from scratch. Okay. All right, so thinking about the process that we just did, let's just do one thing at a time, okay? And to write a program, a lot of times, you have to kind of go back to how you did it by hand first, and then you just look at this process and go like, okay, what is involved in this process? Okay. Well, we'll start with something to represent the value that we are converting. Okay, and what concept do we need in order to keep track of the value that we still have to convert into a certain base?
Well, we need a variable for the value that we want.
Yep.
A variable for all the values that will come out of it if you choose to have different bases.
Okay, very good. So we need several things. We need one thing that we need is a variable to store the value that we are converting. Okay. In other words, this value here needs to be stored somehow, okay, so that it will start with 47.5, then it becomes 15.5, then it becomes 7.5, then it becomes 3.5, then it becomes 1.5, then it becomes 0.5, and then eventually it becomes 0, we're all done, okay? But that needs to be stored somewhere, and the mechanism that we need in a program to store a particular value is called a variable. We're doing okay so far with that concept. A variable is used to store a value so that we can remember, something that we are processing. Okay, so we go back to scratch, and then we go to variables. We make a new variable, and we can make this available only for this sprite because nobody else really needs to use it. And we'll just say remaining value. Okay, remaining value. Now Scratch is kind of nice because you can actually use a space, but that is not a character you can use in general programming languages. In a general programming language, you cannot use a space as a part of a variable name, but Scratch is a little bit different, so it's okay to use a space as a part of a variable name, which really helps to make it more readable. Okay, so we have a particular value called remaining value, okay? And then we can go back and look at the spreadsheet again. And it seems like we are starting with 64 to try to determine how many 64s we have, and then we move on to 32, moving on to 16, 8, 4, 2, 1, 0.5, and 0.25. Okay, so what the first attempt I'm going to make is going to be a little bit tedious, okay? And once I realize the tedium of the process, then the next time, or if I have enough time today, I'll try to make it a little bit more elegant so it's not as tedious. So we'll try the tedious approach first, okay? All right, so we go back to Scratch here, and we'll start the script using a starting block here. The starting block is nothing more than a trigger to say, when do I want the rest of this script to execute? Okay, in this case, it's just when I click the green flag, at the upper right corner of the canvas or the stage, this script will start executing. So it's really just saying, when do we start this script? And this says, when I click the green flag. All right, so what we'll do is we'll go back to the spreadsheet again. So I'll be doing a lot of back and forth here. How did I determine this would be a 0? Do you guys still remember?
Yeah.
It was based on a comparison, right? Okay, it was a comparison. Comparing what? What am I comparing in this case?
It's larger.
Which one is larger? But which two numbers am I comparing?
64 and 47.
64, which is the cell B1, and 47.5, which is the cell K2. Okay? In other words, we are comparing this number against this number here, and in some cases we want to say, yep, we got a 1. And in some cases, we'll say, oh, we got a 0. Go ahead.
If 47.5 is the value, what's 64? What do we call that?
47.5, which is the cell called K2, is the remaining value. 64 in this case is a power of 2. We are trying to determine, do we have 0 or 1 of this power of 2? Okay. So I would just call it, a power of the base that we're converting to. Yep, go ahead.
So why don't we add like 128, 64, 32?
Oh, you can go all the way, but that end.
So we start with 0, 0, 0, 0, 1.
Correct. But you can have
Doesn't
as
matter
many.
how much zeros we have on the left.
You can have an infinite number of zeros because since we don't have any 64s, that means we don't have any 128s, we won't have any 256. So you can pad as many zeros as you want on the left-hand side. to make the exercise a little bit simpler, I started off with 64. Go ahead.
Especially you use arrays.
Sorry?
Arrays.
Arrays can be useful in this case, but it's not necessary.
Yeah.
The logic of this code does not require the concept of an array.
I was just wondering if it had the ability to do so.
You mean Scratch?
Yeah.
Scratch has a concept of arrays. It doesn't call it arrays, but it is similar to the concept of an array. Yep. All right, so we need a comparison. And based on the result of the comparison, sometimes we say we have a 0 of that, and sometimes we say there's a 1 of that. Yep, go ahead.
I'm not sure I'm understanding the 8 and the 9. What are the numbers? 6. What does the 90 mean? 9?
Which number?
The 01, 01, 01. What does that mean?
Well, you kind of missed the first half hour of the class, so it might be helpful to kind of review the first half hour. Because I cannot really go back and re-explain the first half hour of this class. But we are doing base conversion. All right, so now we need a way, for Scratch to use comparison as a clue, but it will branch out in 2 different ways. Because sometimes we say there's a 1, and sometimes we say there's a 0. Okay? We talked about, some of the controls last time. We talked about how many times to do something. That is helpful, but not in this case yet. Okay? We'll make use of that later on. But what we need here is something that can say, well, sometimes we want to go one way and sometimes we want to go some other way. It is called a conditional statement. A conditional statement kind of looks like this. Okay? If for people in the back, I'm not sure whether you can read it. I'll just point to the words and I'll say it. This is an if, and there's a little hexagon here, and this is else. So what this is called a branch. A branch means depending on the condition, depending on the hexagon or the result of the hexagon, sometimes we'll do this part here, whatever is specified between the if and the else. And sometimes we'll perform the other one, which is whatever is specified after the else. Okay? We do things like that all the time in daily life. Give me one example where you have to make a decision, okay, what to go one way or the other way. Go ahead.
Opening up a door, it has a sign that says push or pull.
Opening a door.
It has a sign that says push or pull.
Push or pull, okay? Yep, exactly. That's a decision, because if the door says push, then you have to apply pressure this way. Otherwise, you have to pull it with tension. Yep. Go ahead.
When you make a plan, you have a backup plan. If plan A doesn't work, go to plan B.
Okay, well that's a application of a condition or a branch, but but definitely that's also an application of a branch. Yep.
A fork in the road when you're driving?
Yep, exactly. That's a very good way to put it too. Because you have to determine which way to go. Okay, you have 2 ways to proceed, and it becomes even more obvious when you're at a T-junction, right? So you're going down the street, and now that particular street ends, but it's a T-junction, so you can either turn right or you can turn left. It's the same thing here, turning right or turning left. But in this case, the determination or what makes you go one way or the other is called a condition. Okay, a condition is basically an expression that ends up with a value of true or a value of false. Okay, so that's called a condition. In this case, what are we doing? If I go to operators, can you pick one of the operators to help us out in this case? Don't worry about the details, like what should go onto each side. Just pick a operator that you think is going to help us make the decision in this case. Minus? Well, we don't need to do minus yet. We don't need an or. Come on. Okay, let's go back to the spreadsheet and figure out this part here. We are looking at this number and also this number here. Those are the 2 numbers that we are looking at. And, yep, go ahead.
You want to make it so that if the variable remaining is greater than, or if the variable, like the remaining value, is greater than 64, you make it 1, but if it's less, then you make it 0.
Exactly, that is exactly what we are doing. But then you're dealing with greater than or equal to, which is not one of the operators that is, you can make it up, but it's not given to you as one operator. But I can cheat a little bit here. I can use a single less than to do that. Okay, so you can see how I'm writing my programs here. I'm just dragging and dropping it here. Now this is where syntax does not matter, because you cannot put this somewhere it does not belong. See, it doesn't click. You can put it there, but it's not a part of the program. It doesn't click. But on the other hand, if you put it here, it clicks. It becomes a part of it. So this is why Scratch is really useful, because it just throws the whole thing about syntax, which is the grammar of a programming language, out the window. There's no such thing to learn when you're doing Scratch programming. You try to put it somewhere. If it doesn't fit, it doesn't fit. You cannot put something that does not belong at a place where it does not belong. Okay. So now we have to be a little bit more careful, because now we have to go to variable, and I know one side is 64. I know the other side is remaining value. The question is, well, which way is which way? Now, what you said earlier is absolutely true. If the remaining value is greater than or equal to 64, we go one way, and then else we go the other way. But what is the other way to phrase it? Using only less than.
It'd be if 64 is it's the
Okay, give it a try.
If the amount is less than 64?
Exactly.
Oh, okay.
Exactly. Okay, I think you were about to say that too. Okay, so if the remaining value is less than 64, which is a power of 4, a power of 2, then we want to say there's 0 of 64. Right? Okay. So how do we make Scratch say something? Well, you just make it say something, right? You go to looks, and then you go to say, and you have two choices here. You have one choice that says, say hello, and then the other one says, say hello for 2 seconds. Now, the difference is one is timed and the other one is not. If you go for the one that is not timed, it will only remain on the screen until the sprite says something else. Okay, so if you're doing this calculation really, really fast, then you will see a whole bunch of numbers just flashing by, and you will not be able to see the actual, the value. On the other hand, if you use, say hello for 2 seconds, it will just, keep that message on the screen for 2 seconds, and then it will disappear, and then the program continues its execution. Is that working out so far? Okay. So we'll just go for, say hello for 2 seconds, except I'm not saying hello in this case. What should I be saying? 0, exactly. I'm just going to spell out 0 here. In other words, the sprite will be saying zeros and ones, and each digit will take up 2 seconds. I think 2 seconds is a little bit of an overkill. I think we can probably go with just 1 second. Okay, so we'll go ahead and change 2 seconds to 1. And then what do we put here? We already figure out that if the remaining value is less than 64, we want to say 0. What about the alternative branch? What should I do over there? What does it mean if I go for the alternative branch? If I don't go here and I end up over here, what is it saying about remaining value versus 64? Go ahead.
Say 1.
Say 1 because the alternative means remaining value is less than 64 is false, which is a fancy way of saying remaining value is greater than or equal to 64. But in those cases, I want to say 1. Is that making any sense so far?
Yeah.
Okay. So we'll go ahead and use say again. Just drag it over. Oops, wrong place. There we go. And this time we say 1 for 1 second. Okay, that's kind of cool. And how do we get remaining value? Remaining, go ahead.
After the say, I just said it's variable to, or remaining value to remaining value minus 64.
Okay, we'll do that. But first of all, we have to kind of get a particular value into remaining value, right? So I can do one of two things. I can just hard code this. This is called hard coding. Hard coding means every single time this program runs, remaining value starts with the value that we were dealing with. I think it's 47.5. Is that right? Let me double check. Yep, 47.5. This program is not very flexible this way, okay? Because every single time you run this program, it only converts 47.5 into a binary number. But you know what? It's okay for us at this point, okay? Because we don't want to make this program exceedingly difficult or complicated at this point. We just want to make it so that we can show the logic first, okay? And I know we have to do the subtraction, but I'm not even so worried about the subtraction. I want to test the program as it is now to see whether it will give us a 0 instead of a 1 to begin with. Is that making any sense? Okay? Because I just want to test the program. Well, it's pretty easy. You just click the green flag, and it says 0. Yay, it's working. Okay? What about the other value? What about this 74.25? That is supposed to have a 1 for the 64, right? I might want to test that too. Okay, so I go back to the program. I change how I initialize remaining value to 74.25, I think. And I run the program again. And this time it says 1. Yep. Okay, the program seems to be working up to this point. Now, this is very important, especially for those of you who are moving on to another programming class, cisc310, which has no prerequisite. Or for some of you, you might have taken cisc300 already, and you're ready to move on to cisc360. It is very important to write programs in small steps. Okay? Don't try to write a whole bunch of lines, like 40 lines at a time, and then try to debug the program after that. Write something like this. Test the program to see whether it works or not. Okay? Because if you write a program like this, which basically translates to about 5 lines in C and C++, Visual Basic about the same, 5 to 7 lines. If it goes wrong, how many lines possibly can be wrong? 5 to 7 lines, right? If you write 70 lines before you test the program and the program does not behave the way you want it, how many lines can be contributing to the problem? 70 lines, okay? So do you think it's easier to find flaw within 5 to 7 lines or 70 lines? 5 to 7 lines is a lot easier to deal with, right? Okay, so that's why we want to test programs, very gradually, take baby steps, even though it seems like, what a waste of time, okay? But I can tell you, in the long run, it's saving time because you don't have to look at all 70 lines and go like, okay, now what is wrong with it, right? Because if I did make a mistake here, it's easy to spot and easy to fix. Okay, so I'm going to make a mistake here. What I'm going to do is to say, oh, okay, we can convert the binary number, and I now know how to deal with this number. I just compare this number to this number, and use the same logic. Okay, if the remaining value is less than this particular power of 2, I say 0. Otherwise, I say 1. All right. In Scratch, that's a really easy way to do this. You take the block that you want to replicate. You right-click on it. You say duplicate. And now we have a duplication. And then you say, well, I'm pretty smart. I know that this is not supposed to be 64. This is supposed to be 32, right? Okay. Now, some of you already know that I have just made a mistake here, right? But that's okay, because I want to show you, how the program will behave when I make a mistake like this. Okay. All right. So I'm going to test this program with 47.5 first. 47.5. And according to our spreadsheet, 47.5 should first print a 0 and then a 1. Is that right?
Yeah.
So we'll test the program. You click the green flag, says 0, 1. Yay, it's working. But I'm not quite done yet, okay? I want to try this one with the other value that we have, which is 74.25. Okay? And we'll test the program again. 1 is good. 1 again? What? The program is not working. Okay, it's not working correctly because the second digit for the second number is supposed to be a 0, not a 1. Okay, so now I know that something is not right about this program, and why would it say 1 in this case?
Never change the variable.
I never changed the remaining value, right? Because when I perform the second comparison, I'm comparing to the same value, the same remaining value. I did not take into account that, oh, in this case, I have already taken care of 64 out of 74.25, and I only have 10.25 to deal with after that point. I forgot about that. Okay, well, that means in the program, I better do something to fix it, right? If I say 0 for a second, I don't think there's anything to do because it simply means that the remaining value does not contain any 64 or 32. So there's really nothing to do when I'm supposed to say 0. But when I say 1, it means the remaining value has 1 of that particular power of 2, and as a result, I should subtract that amount from the remaining value. Is that part making any sense? Kind of? Because that's what we did by hand. When you go back to the spreadsheet, this is what we did by hand. 47 versus 32. Okay, when we get to this part here, we say that, oh, there's 132 in 47.5, but once I give the customer a $32 bill, the remaining value is only 15.5. Okay, and how do we get 15.5 from 47.5? We subtract the power of 2 that we just dealt with. Okay, very good. So that means we have to go back here, and in Scratch, there's a really easy way to do it. I can say change something by a particular value. So in this case, I can stash it here and say change remaining value by negative 64. Because if you say 64, it will increase it by 64. When you say change by a negative value, it is decreasing it by 64. Are we still doing okay so far? So we have to do the same thing with the other block too, because they are supposed to be the same thing. So we have to do exactly the same thing. I can just duplicate here and stash it over here, change this negative 64 to negative 32. And well, before we proceed any further, even though I was kind of sure that this is the fix, should I just trust myself and just, we'll move forward?
Test it.
I should probably test it again. Okay. When I test it again, I will go back and test 47.5 again. Even without this fix, 47.5 was working, there's always a chance that, quote unquote, a fix is going to cause problems. Okay? So when you're retesting a program, you always retest with, all the values that you can use for test cases. Okay? 0, 1. Okay, that's good. Okay? It was working before and it's still working, but you can also look at remaining value. It changed. Okay? It changed from 47.5 to 15.5 because it remembered to subtract the 32. And that's great because that's exactly what it's supposed to do. Are we doing okay so far? Yeah, all right. Then we should try it with the other one, which is 74.25, because this one should give us a 1 and then a 0. Okay, so we click the green flag. It says 1, 0. All right. Okay, so things are working out, at this point. So what do we need to do? Well, we just need to replicate this logic a few times, and we are done. Now there is one inherent, potential danger of doing this, because you have to change both 32 to 16 in this case. What happens when you only remember to change 1 to 16, but forget to change the other one to 16? Then the program will not work in some cases. Okay? Because if I forget to change the highlighted negative 32 to negative 16, then the program will only not work when that particular branch is taken. So depending on your test cases or what numbers you use to test the program, you may or may not catch it. So we'll later on we'll figure out how to get this program to a point where I cannot really make mistakes like that. Okay, if I make a mistake, it's going to be consistent and throughout the entire program. But in this case, I'm just going to have to remember to change both 32s to 16s. And then when I replicate this again, I have have to change the 16 to 8 because that's 2 to the power of 3. And then we replicate it again. Yes, this window can actually scroll, so you can actually write fairly large programs using this particular method. That replicate again. I put it into the wrong block. I put an if inside the if. Okay, that's good. 2. Are you guys getting bored? No. Well, you should be, because this is really tedious, because I'm just doing the same thing again and again, except I'm making the power of 2 1 less than the previous one. Good. Once again I put it into the wrong block. Just drag it out, and it's really about the same as dealing with folders in Windows. You're just dragging a folder in and out of another folder. Okay, one more time and we're done. .25. Now the .25, you really don't have to do it, but I'm doing it just so that in case we have an eighth of a dollar and a 16th of a dollar, this program can continue to kind of stack up like that. Okay, if I were to ask Scratch to say a dot, the period, where am I supposed to put that? I have to put it here, because that's the point between the unit and the fractions. Okay. So here I just say, click, point, okay, for 1 second. There we go. All right. So now let's go ahead and run the program again and see whether it's going to give us the output that we are supposed to see. Okay, so we'll start with 47.5. It's supposed to give us 0, 1, 0, 1, 111.10. Okay, are you guys remembering that?
I got it written down.
You got it written down. Very good. Okay, so 47.5, and then we click the green flag. 0, 1, 0, 1, 1, 1.10. Now, the only problem is you cannot see when there are consecutive ones. It's really hard to see whether it's saying just the original one or whether it's saying a new one. Okay. Okay. So, but it is working. Let's try the other value, which is 74.25. 74.25. Click the green flag again. 1, 0, 0, 1, 0, 1, 0.01. And I think that's the right number. Okay. So the program is working. Okay. Some people look at this program and go, "It's working. I'm done. There's nothing else to do." Well, I look at this program and go like, if you compare the blocks, okay, if you compare this block with the next block with the next block, I see a lot of similarities between the blocks. What is the only thing that is changing between the blocks? The numbers, okay? Now, the 64 becomes a 32, 32 becomes 16, 16 becomes 8, blah, 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 blah. Are they random?
No.
They're not random in any way. How are they related? Powers of 2, right? We start with 2 to the power of 8. 2 to the power of 6 is 64. And then we have 32, which is 2 to the power of 5. Then we have 16, which is 2 to the power of 4, and so on. So, I'm thinking that we can make this program, change this program a little bit to make it more self-consistent. Okay. In other words, in this case, I'm going to use another variable to keep track of the power of the base. Okay, I'm going to make a new variable in this case, only for the sprite, and call it, in this case, power of base. Okay. I'm calling it power of base, so later on I can change this program to do with base 5 and whatever odd base you want to deal with. All right. And with this new variable, I'm going to initialize it before the whole thing. In other words, I'm going to initialize that to 64. Okay? So that means, here, instead of comparing to 64, I can just compare that to power of base. Is that making any sense so far? Instead of the 64 here, I compare it to the power of base. How about this negative 64? Because 64 is 64. How do we change 64 to negative 64? Well, this is actually kind of cumbersome, okay? Because what you need to do is to use subtraction. Because you have to specify. There's no stop. Okay. There's no unary subtraction, so you cannot just negate a number. You have to say 0 minus a variable. Okay, that's the only easy way to do this. There we go. Okay. Do you think this program will still behave the same way?
Yeah.
No. Why do you think it's not going to behave the same way?
Because the power of base doesn't change.
Well, but I only have one block changed so far, right? Okay. So, but you're absolutely right. I only changed one of the blocks. So if I were to use the same approach with all the other ones, okay. So I'm trying to be a little smart here and say I don't need that anymore. I just need to replicate this block like several times and I'm done. But I can't because the power of base is always 64 in this case. In other words, if I just right click and say duplicate and then right click and duplicate, I'm going to use 64 for all the comparisons, which is not going to work, okay? Because I can just test it. Run it again, 1, 0, 0. Well, that's not what I'm supposed to see. If I change this to 47.5 and hit the green flag, 0, 0, 0. It's not working. And it's because the power of base is always 64. It's not changing to 32, it's not changing to 16, and so on. What is the easy way to fix this?
Change power of base.
Yep, change it. Okay, so we have to use, in this case, we have to use set because we cannot say change by. I suppose we can use change by, but using set is more general. What are we setting it to? What should be the new value of power of base? Yep.
Power of base
Divided by 2? Okay, well let's use division by 2 here. So we will say, power of base, the new value of power of base is, okay, we have to use operator because we have to use division here. And it's going to be power of base, oops, go ahead.
What does that say by change mean value by, is that 0 plus? Or
0 minus. This is 0 minus power of base. Yeah, I know the contrast is really poor, on the screen, so it's hard to see it. All right. So now that we have our blocks looking like this, maybe we can give it a try. Okay. So we toss this away, and then we drag this block out and say duplicate. Oh, okay, so I have a quick and easy way to do it. Okay, see now we have 2 blocks here. If I duplicate this, I end up with 4 blocks. If I duplicate that again, I end up with 8 blocks. But now I have to know how to scroll down. It doesn't make it easy. Okay, I have to drag this and paste it over here. Okay, how many do we have now? We got 1, 2. Well, we'll just give it a try now. I know the decimal point is gone, but we'll try this particular program at this point. So this is 47.5, and we'll hit the green flag and say
It's not going to work.
It's not connected.
oh, because it's not connected. We have to reattach it. There we go. 0, 1, 0, 1, 1, 1, 1. And if you go back to the spreadsheet. Yep. It missed the last 0 because I didn't have that one. Okay. But now when I look at this program, but why would I change the program like this? It seems like I'm doing this to make the program more complicated for no apparent reason whatsoever. Or do you think I'm doing this for a particular reason?
It makes it simpler by putting the variables in there. You can add things to that program.
Okay.
It automates the process.
It automates the process. I think what you meant is I'm repeating exactly the same thing over and over again. Okay? Because earlier, when we were using 64 as a number, 32 as a number, 16 as a number, the blocks are similar but not exactly the same.
Wouldn't that be a loop?
Now I can turn it into a loop. Before, I cannot turn it into a loop because each time it is repeating itself, it's a little bit different. Okay? But this time it's identical. Okay, can everybody understand what I'm saying? I know it's really hard to see because it's really busy. So what I'll do is I'm going to isolate the blocks, into individual ones. So I'm going to take this one out because I won't need that. If you look at these two blocks here, do they look identical to you or are they just similar?
Identical.
They are identical. In other words, I have turned the program from similar blocks into identical blocks. Now, when I have identical blocks, I have a way to make the program much easier to read. And it is something that we talked about last time. What is that one thing that we were able to do last time? Instead of spelling out this block 9 times, I can now just say, hey, do the same block 9 times.
Looping.
Looping, exactly. Repetition. Okay? It's also called iteration, loops. So, yep, exactly. Repeat until. Okay? Repeat so many times. So now we can actually use that mechanism instead of repeating, just replicating the blocks. Why would that be a better approach? Is that a better approach, or should I be just duplicate the blocks 8 times and be done with the program? Which one is a better approach? Loop is a better approach. Why is that a better approach?
Easier to read.
Easier to read. The program is shorter. Okay, and that's how bloatware happens. Is when people copy and paste unnecessarily, then your program bloats up and becomes really big. But when you try to make your program compact and elegant, then your program will remain kind of small and efficient. All right, so we don't need this block anymore. We go to control, and then we go to repeat. And when you apply repeat, did you see what happened? Okay, I can put it, right here, and it automatically says, oh, I'll just repeat this entire chunk of the program, 10 times, which we don't really need 10 times. We just need I think 9 times. Okay, so we'll stash it here. And then we go back to the spreadsheet and count exactly how many times we need. 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly 9 times. So we put a 9 over here. So we're almost there. Okay, let's test the program again and make sure that we didn't break anything in the process. Now, I forgot to demonstrate one thing that is really, 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 really important. As I was making changes, did I save the file?
No.
So what if, now I know most of you are thinking, but what if there's a power fail, right? Well, that's not even what I'm worrying. What if I made a stupid change and broke the program, and I cannot remember what I did?
You have to go back and redo it?
Exactly. So when you're writing programs, okay, especially in a class like 360 or 370, where you'll be writing relatively long programs, before you change a program, okay, you look at a program that's already partially working. You know it's working up to this point. It's working for these test cases. You want to save the program first under a different name, and then you change it, and then you save it under a different name. So in case your change made the program worse or broke the program, you always know what it was like before that one change. Okay, that's something that I did not do because I was probably overconfident, in the process. Okay, but overconfidence, will cost you. Okay, as it cost me in many cases. All right, so let's test this program, and the spreadsheet says it should be 0101.111.10. Okay, so we'll run it. 0101. 1, 1, 1, 0.10. Okay. Okay, the only thing that's missing is the point. Okay, because Scratch is supposed to say something about a point. Where am I going to put that point? Well, now that it is a loop, it makes it kind of hard to put that point, right? I have two options. I can turn this loop into two loops. Okay. In other words, I can make it repeat 7 times, and then make the sprite says point, and then repeat it twice more, as after the point. Or I can put something into here so that when at the right time in the right iteration, it will say point. Okay. I got 2 options like that. Yep.
Second one is going to be a variable that adds +1 every time it repeats, and when it hits a certain value, it says.
But you know what? I have that value. I have an indicator already. In other words, I have what is necessary to make that decision. Should I say that point or not? Okay. What? Do we really have that value already? Well, remember this number is now remembered as power of base. Remember, power of base was 64 to begin with, and then with each iteration, I divided by 2. So 64 becomes 32, 32 becomes 16, 8, 4, 2, 1, and then it becomes 0.5, right? There's a transition from 1 to 0.5. That is where I need to spell out that period, the point, the decimal point, or in this case, the binary point. Okay, so I know I have the indicator. When the value was 1 and it's becoming 0.5, this is when I need to spell out that 1 point. If you look at the code here, where am I supposed to? Oh, first of all, I know that sometimes I'm supposed to say point, and other times I should not say anything. So what type of statement should we use in this case? A conditional statement, an if. Very good. Okay, so let's go to the control part here and pick out the if. Now, personally, I always use this one, even when there is nothing to do on the other side. Because just in case there is, I know where to put it. It doesn't cost you anything. Okay, it's not like if you have an empty branch, the program takes longer to execute. It just looks kind of weird because it's saying, oh, here's a space to put something just in case we need to put something there. Okay, but I don't really need. It's no worse than using the just the if. Okay, so what I'm going to do is to say, okay, should I put it here or should I put it here? Well, you know what? It doesn't matter, okay, because I know the effect of this statement here. In other words, I know that if I put it under, power of base would just be 1/2 of what it was before. So if I can do it before, I can do it after. Either way works. Okay. If I do put it before, what do I need to put into the little hexagon here? In other words, when am I supposed to say dot? Spell out the period. Well, let's take a look at the spreadsheet here. 64, no, okay, when power of base is 64, nothing to do. When it's 32, nothing to do. 16, nothing to do. 8, 4, 2, when it's 1, I'm supposed to say period. Right? So, which operator should I use in this case to determine, oh, this is the right time, I should spell out the period? Equals, very good, okay, because I'm looking for a particular value, so equal fits the bill. So I put it over here. What am I comparing to what? I'll give you a hint. I'm using one of the variables for the comparison. Which one should I use? Should I use power of base or remaining value? Power of base, okay, so since equality is symmetric, I can put it on either side. What should I put on the other side? When power of base is something, I'm going to do something. When it's 1, very good. Okay, so when it's 1, I will just go to looks again, and this time I'll say period, a dot, for 1 second. All right? So now we want to test the program and see whether it will spell out that period. 0, 1, 0, 1, 1, 1, dot, oops, there's 1 more 1 dot, 1, 0. All right, it is working. Now, it is still kind of hard to tell, when the digit is changing. Am I looking at the same one as before, or is it a new one? Okay, that's really hard to see. So what I'll do is I'm gonna make Scratch walk a little bit, change the costume, so that visually we can see that, okay, this is a new digit. Okay, so I can go to looks and just say next costume. Okay, I can put next costume all the way at the end of the iteration. So at the end of each iteration, it will change its costume, so to signify the change. Okay, is that okay so far? Now, if I did not use a loop like this and use the replication method, I would have to make changes to all of the blocks that I've duplicated. Yep.
Under the next costume, can't you put the other thing we did, the 74.25? So after it changes the costume, we can do that.
You can do.
You know how we changed the number from 47.5 to the 74.25? So
Right.
for the costume, we could just repeat and then put the 74.25.
Oh, you mean to test the program using another number?
Yeah, so then it'll change the costume and then do the
There's a better way to do it. So I'll describe that method later. Okay, but that's a good point. It is a good point. So this way I will test the program again. 0, 1, 0, 1, 1, 1, 1, point 1, 0. Do you see how the change of the costume makes it kind of easy to tell, oh, this is a new digit, right? Just visually you can see it. Okay, so to answer your question, we want to make this program a little bit more flexible so it's easier for me to change what number I'm using to test it, right? Okay, so to do that, what I'm going to do is to make the program just a very small change here. I go to sensing, and I'm going to ask a question. And the question is, give me a number to convert. And then once I have that, the remaining value is going to be the answer to that question. So now the program is very general because it will just ask me which number I want to convert. I type in the number, it will just go ahead and convert that number. Right? Let's try this one more time. I know we are running a little bit over time. So I would try 0, which is a really obvious case, right? Because if I give it 0 to convert, I should get all zeros as the output. 0, 0, 0, 0, 0, 0, 0, point 0, 0. Okay? So I'm going to end today's class here because we are running out of time. On Thursday, we'll have our exam. Okay? It's open book, open notes. I will give you the paper to do it. You don't have to bring any Scantron. If you feel a calculator is helpful, bring your calculator.